When developing a website, you want to make sure that it can interact or deal with as many possibilities as possible. So this week we are touching on MySQL, commonly spoken as MySQL, as well as Java-enabled SQL databases and how they might relate to our web applications. As I've mentioned in the previous weeks, all prior work assignments, projects are posted on the website's web space after they are due and organize them in one specific area so you can FTP everything up in preparation of the final project. JDBC stands for Java Database Connectivity. This is commonly used with databases in SQL or SQL in order to get information from the web using Java code. It connects databases and also can handle SQL queries and responses. It is an application programming interface, more commonly known as API. Commands are sent within the Java database connectivity using the Java programming language. We've seen this previously, that Java helps us a lot with JavaScript, Java server pages, and now Java database connectivity. There is a java.sql package which features the driver action function, which implements a driver. You've been provided a resource within the info page for this week, which touches on the java.sql package. The JDBC is a feature of Java function libraries, a combination of various Java actions we can take. Using just a single Java program, we can connect to several different databases. Specific to load a JDBC driver, we can use class.forName and our variable. In this case, we're using an Oracle driver. Oracle is quite common with database concepts. It's a connection object within our code. We also need a statement object with a prepared statement and a callable statement. The callable statement is what's done. There's also a possibility of a question mark symbol, which represents a statement parameter. It's determined at runtime. You may not know it beforehand. Result set object holds the results of whatever query you have done. Here is an example. You'll notice we import our Java classes, and we specifically need everything within our java.sql class, so we use the asterisk to include everything inside. In this case, we are creating specific pieces of data within our table. In this instance, they're strings, a salary of double. We are asking for input for our database account and a password. And ultimately, we print out the person's last name and their salary. Here's another example. Somewhat similar, however, we change up some of the variables. We're missing a few from the last time. We're asking for the same inputs again, database account and password. And again, we print out last name and salary. So why do we want to use this? Well, we can make a connection to a database without necessarily having any knowledge of SQL, because we can use Java to create SQL or MySQL statements. We can also execute them in order to query information, as well as viewing or modifying the results that we find within our record. So how does this work? What does it work with? Well, Java applications, Java applets, Java servlets, Java server pages, all of which we've touched on to some degree previously, as well as enterprise Java beans, which these days is a little less used, but still works well with Java database connectivity. So here are some other important Java packages in addition to java.sql, which is Java SQL, as well as some classes within Java X.SQL. And you could see specifically what their purpose is on the right-hand side. The two aspects we will focus on this week for your assignment is result set and result set metadata. Result set provides you with your result set. Whatever you specifically were looking for when you queried the database is produced out. The result set metadata is an object that can be used to get information about the types and properties of the columns in a result set object. So metadata is data about the data. So what are assumptions? You're asked to create assumptions for your assignment this week. These are specific informations or assumptions, claims that an individual assumes to be true but may not be obvious to other people. So for example, I assume you're reading these PowerPoints and not just watching the video lectures. That may not be true, but that is my assumption. Some of you may be doing it, some of you may not, none of you may. Again, that's why it's an assumption. So in building assignment 13, you're creating a table where you list your course, instructor, and credits. So in the column for course, you have the course number and title, your instructor, and the number of credits. In my example here, I have the 2 courses I'm teaching at Seton Hall this semester. Yours will be however many courses you're currently enrolled in this semester. Then we need to create our assumptions. So I created these assumptions based on database knowledge. The data can be edited to add and remove input as needed. We might need to split up course into course number and course name at a later point. That would create 2 specific columns for that currently listed as course. The course data type I have set up as varchar number. This means you could have any variable number of characters. Numbers, letters, anything you may need, because this helps us figure out what our course is. If we have it only set as integer or text or string, it will limit what we can do. Ideally, we set the number to have enough characters to account for any input of courses. The instructor data type will be text to allow only text. Obviously, nobody's name is going to have a 3 in it or a 6. So we need to have enough letters with our number as well to account for input. And then for the credits data type, I have set it as int1 to allow for one number as input. This is due to all credit possibilities, all being only one integer. 1, 2, 3, 4, 5. I've never seen a 10 credit class, so this is the assumption I make. You may do the same kind of assumptions, or you may have your assumptions written in terminology you might understand better than specific to database concepts. And that is the end of our information for this week on Java database connectivity.